Hey everyone. In this practice video, we're going to be using truth tables to test whether statements are tautologies, contradictions, or simply contingent statements. The difficulty level for this video is easy. And with that, let's just go ahead and dive right in. The difficulty level for these problems is easy, so we'll be taking things nice and slowly, and then in future videos, we'll ramp up the difficulty a bit. So let's just go ahead and get started. I'm going to zoom in a little bit because I feel like there's really no need for this to be quite so far. Okay, so I'm just going to go ahead and solve this. And remember, we're just testing to see whether the statements are tautologies, which means that they are true on every row, contradictions, which means that they are false on every row, or contingencies, right? They're contingent statements, which just means there's at least one row where the statement is true and at least one row where the statement is false. So before we can evaluate this conditional, which is our main connective, we need to know what the value of not f is. F is true, true, false, false. So naturally, not f is just going to be the opposite of that. So false, false, true, true. And now we can go ahead and evaluate the conditional. As you'll remember, conditionals are false when the antecedent is true and the consequent is false, and otherwise they evaluate to true. On these first two rows, the antecedent is false, so we know automatically that the conditional must be true. And then down here, we can see that the antecedent is true and the consequent is true, so that means that this will also evaluate to true. And then on the final row, the antecedent is true and the consequent is false, so this row is going to evaluate to false. Just for the sake of clarity, I'll go ahead and I'll highlight the main connective. And as you can see, we are dealing with a contingent statement. Why? Because there's at least one row that's true, in this case the first three, and at least one row that's false. And it's really that simple, that easy, that straightforward. Okay, let's move on. Let's zoom in on this one as well, just to make it a little bit easier to see. Okay, so again, nice, simple, straightforward. We have a conditional as the main connective, but before we can evaluate this conditional, we have to evaluate this conditional here within the parentheses. As always, when you're evaluating truth tables, when you're evaluating statements, you need to start in the innermost statement, right? The innermost connective, and then work your way outward. So let's see here. If truth implies truth, that's true. True implies false, that's false. False implies true, that's true. False implies false, that's true. And now we have everything that we need to evaluate the main connective, right? So in this case, we are going to look here and here. So on the first row, true implies true, that's true. False implies false, that's true. True implies true, that's true. And false implies true, that's also true. I will highlight the main connective, and as we can see, this statement is a tautology. Again, nice and easy, and I have no idea why my Y came out quite so curly. Okay. Let's move on to the last statement. We are just breezing through these. So let's see, get that nice and centered. Man, this thing freaks out, huh? Okay, that's good enough. So here we go, already nice and set up for us. This one's just a little more complicated, right? But it should be easy enough. So before we can evaluate this conjunction, which is the main connective, we need to evaluate this negation. But before we can evaluate this negation, we need to evaluate this conditional. So we'll start there. Truth implies truth, that's true. Truth implies false, that's false. False implies true, that's true. False implies false, that's true. Now that we have these values, all we need to do is evaluate this negation. So we'll just invert the values. Since we have true, false, true, true, this will turn out to be false, true, false, false. And now, of course, we have everything that we need to evaluate the conjunction of G and this conjunct over here. So false and true, that's going to be false. True and false, that's going to be false. False and true, that's going to be false. False and false, that is also going to be false. So this statement is always false, which means that it is a contradiction, right? It's a statement that can never be true under any sets of circumstances. And it's that easy. There's really not much that goes into these, especially when the statements are as simple as this. And that pretty much wraps that up. As you can tell, these were pretty simple, straightforward truth tables. I'll be uploading intermediate and hard videos testing for tautology, contradiction, and contingency, so make sure to keep an eye out for those. If you'd like to see more videos on logic or philosophy more generally, you should consider subscribing. Thanks for watching.